Okay, so let's get back to why output-based rebating maybe isn't a terrible idea. And we gave these examples before. I want to at least talk a little bit about the emissions leakage case. So when you have incomplete regulatory coverage, this could be because of jurisdictional differences, but it could also be, like as in the EU ETS, for reasons of expediency. You start out and you just cover the largest emitters, and you're not covering the whole economy. So there are some emitters that aren't part of the program, maybe because administratively it's just too expensive to include everyone. Okay. So, so with here, this is a paper I have with Alain Bernard and Alan Fox. We have two sectors now, a two-sector model. And sector 1 is going to be regulated. Sector 2 is unregulated. So we're putting emissions price in sector 1. And of course, so what is our first best policy? So, well, let's make sure that everyone pays the same emissions price. Okay, that would be the optimal, to tax emissions of sector 2 at the same rate. But suppose we can't get at sector 2. What do we do then? And climate change is a big issue and arises in large part because of this respect for common but differentiated responsibilities. So it's recognized that developing countries don't have the same obligation to take on the same kinds of burdens as developed countries. But at the same time, especially emerging economies like China, India, South Africa, can be major emitters. And so you're not capturing all the emissions with the same incentives. So what do you do then if you can't directly tax the emissions of this other sector? Then the second best thing is, okay, well, let's tax the product according to its embodied emissions. So you lose that incentive for them to reduce their emissions intensity, but at least you're correcting the price signal for consumers when they're deciding, if they can substitute between these two goods, that they take the emissions, embodied emissions into account. For example, doing this for imports, you can do this with a border tax adjustment. Have any of y'all heard of that debate? So this came up during the U.S. Debate. The Waxman-Markey bill actually incorporated this, again, because of concerns for competitiveness and emissions leakage. And so the idea would be when a product arrives at the border, then you tax it based on its embodied emissions if it hasn't been subject to similar emissions pricing in the country where it was produced. Of course, this doesn't get at foreign goods that are consumed elsewhere, but only in your own country. This is a very controversial policy, using a trade measure to try to get at emissions, essentially, because we have a lot of trade agreements that promise to reduce barriers, not put them up. So suppose we can't tax those goods either, then we're into the at least third best policy, which is going to be, okay, let's subsidize the regulated sector. And so to try to minimize the distortions from this option to substitute to the unregulated good. But then the question is, okay, how much do we really want to do that? How big is an optimal rebate? And so we work through this, and we find that it's going to be larger the closer substitutes are. So imported steel versus domestic steel, those are very close substitutes. So the optimal rebate is going to be likely closer to 100% rebating. If these goods are unrelated, so say you're putting an emissions price in your electricity sector, but not your transportation sector. Is that a reason to subsidize electricity? They're not, you know, well, until we have massive electrification of transportation, they're not really close substitutes. Or if in often case, they can even be complements, electricity in manufactured goods. So then rebate is less justified in that sense because you're not worried about the substitution so much. It also depends on the relative emissions intensity. So when the unregulated goods are more pollution intensive, so then that contributes to more leakage. To the extent you substitute to them, you're increasing emissions. So that's an indication that your optimal rebate is going to be higher. Now, the 100% refunding is just sort of an arbitrary thing. That's like, okay, we want this program to be revenue neutral. We don't trust the money in the hands of the government or whoever else. But that's just an arbitrary number. It's unlikely to be optimal. And the question is, is the optimal closer to 100% than 0? Okay. And the other lesson is that each of these restrictions is very costly in terms of welfare or the cost effectiveness of your program. So, okay. So this is looking at the effectiveness of emissions pricing. Okay, I guess cost effectiveness is the next slide. So here we have emissions, and this is how much emissions reductions then that you get with your price. So here's, say you set the price at the damage, marginal rate of damage. So this is dollars per megaton in this case. So with our first best emissions pricing for both sectors, we see that we get very strong and increasing emissions reductions. Now our second best, okay, we can't directly price the emissions of sector 2, but we can tax it. You know, at least let consumers know that it's emissions intensive, and that's a big gap. You don't get, so this is a tax on sector 1 and an emissions tax on sector 1 and a production tax on sector 2 or consumption tax on sector 2, and it's much less. And then we go, okay, well, suppose we can't even do that. We can't tax sector 2 either. Let's put on the optimal rebate for sector 1 in conjunction with the emissions price. Again, you know, quite a bit fewer emissions, and then the difference between that and 100% rebate isn't very much. So, and that is going to be what really drives what's going on with welfare. Okay, so this is the basically welfare gains from your policy is a share of the optimal gains. So, so optimal being when you can price the emissions for both sectors. If the best you can do is just tax the output of the unregulated sector, then already you've lost, you know, 3/4 to 2/3 of the welfare gains from your emissions policy. Okay. If you can't tax them either, but you can give an optimal rebate, your whole policy you can only get, what, 10 to 15% of the welfare gains of the optimal policy. So this is a really costly constraint to not be able to implement first best emissions pricing. But you know, it's better than no rebate at all, where you really have a hard time getting anything. Okay. I talked a little bit about labor tax distortions. So let me just get a little bit in. I don't want to go through all this. But you, just noting that, So your optimal, this is somewhat analogous to the previous paper. Now we have a tax interaction. So your optimal subsidy, your optimal rebate is going to depend on both this marginal leakage impact, so which is bigger the more emissions intensive sector 2 is and the closer substitutes that they are, but also this tax interaction factor, so how sensitive the labor market is to changes in consumption. And let me just get a little bit, because I want to leave plenty of time for Thomas, but I want to talk a little bit about just that output-based rebating, at least particularly in sort of the climate, as a climate policy mechanism and being concerned about emissions leakage. This is fundamentally a trade issue. Trade in manufactured goods sort of drives a lot of the ideas behind this, but also trade in energy goods. These are global markets, and so most of the analysis in this literature has been done with computable general equilibrium models. So basically big models that were built to look at trade policies that have now been adapted to incorporate emissions and then think through about how different climate policies affect global trade and thereby emissions. So that's sort of the way that these have been looked at. Well, okay, so this is a paper I have with Alan Fox that just shows the role of tax interactions as well as leakage. And so you find that we can actually, if we can actually auction the revenues and use that to recycle the revenues to lower taxes, so reduce this labor tax distortion directly, then that's the best thing. And then you do want some output-based rebating to deal with leakage, and so then you just want to focus on the most energy-intensive trade-exposed sectors. So so this is you see, so A1 here is auctioning with output-based rebating just for those energy-intensive trade-exposed sectors. A0, so we're comparing this to auctioning alone with revenue recycling. A2 here is, well, so suppose we also give output-based rebating to the electricity sector, which is in effect what they were proposing in the US and what they did in the first phase of the EU ETS, because they're afraid of raising electricity prices for consumers because consumers vote. But that's less efficient than recycling those revenues directly to lower taxes. On the other hand, though, if you're not going to do revenue recycling and you're going to grandfather whatever remaining emissions values there are, then that's a different story. And in this case, you can actually have situations, you always want to do some rebating for the trade-exposed sectors because there's leakage associated with that. But in this case, you can actually even do better, and you certainly do better than not with also rebating in the electricity sector, because electricity prices don't go up as much. There's less interaction with the labor tax. So that's just a little evidence for the importance of tax interactions, and it can change your relative evaluation of grandfathering versus output-based allocation. But I just want to talk a little bit about the distributional effects of output-based rebating versus border adjustments. So there's a lot of reasons to think that border adjustments are actually more efficient in terms of getting at the leakage question, because you're taxing them. So then you're passing on the price signals to the consumers, and they make better decisions about trying to find less energy intensive products. So using less steel in cars, finding alternatives. and it more directly gets at, then you can in theory discriminate among your trading partners and put a bigger tax on the more emissions intensive ones and a lower one on cleaner goods. Whereas a rebate is just a rebate, and you're trying to use that to offset, your average cost increase. But both of these policies they are types of trade measures, and they do have effects on your trading partners. This is a paper with Chris Boehringer and Knut Einar Rosendahl, and so we're looking at sort of the internationally distributional effects of these policies. Suppose the US and the EU got together and each had emissions target, and we're trying to reduce, say, 20% of emissions, I think was the target here. So what are the consumption effects, and how does it depend on whether you're auctioning? And here we don't have labor tax distortions. We're just looking at the leakage. Whether you auction it, whether you use output-based rebating, or whether you use border carbon adjustments, which for short, we have tariff here. So here in the US, the costs are not that big, but they're lowest with the with border adjustments, and the same in the EU. So output-based allocation, this is just for the energy-intensive trade-exposed sectors. It does improve, make the target less costly. As these are global, we're trying to meet a net global emissions target to keep this, the comparison even across. And so if you have leakage, then you don't have to do as many reductions yourself. So border carbon adjustment is the least costly for the implementers of the policies. So then the other things to notice here, okay, so here are some of the emerging economies that are often foster the inspiration for protectionist measures in our countries. And we see here that they are, if you compare, well, first of all, for the most part, except for India, for various reasons, for the most part, just the fact that we are imposing climate policies upon ourselves imposes costs on these other countries. It gets transmitted, okay? Because it changes our consumption patterns. It changes the total amount, our incomes, how much we have to consume, and that it affects the global economy. And so there are costs in these other countries as well. In fact, the highest costs, you'll see Russia and OPEC. Okay, some of these costs get transmitted in terms of the prices of energy. We reduce our demand for fossil fuels, that's going to decrease their value. And these guys lose a lot of rents. So in welfare terms and percentage terms of their consumption, our climate policy is way bigger for these guys than it is for ourselves. So that's one thing to notice. But then also our trade partners, so these, a lot of this, these policies are really concerned with the internationally competitive manufacturing, okay? And so we tend to look to these countries. And also just that, and that India number, a lot of what's going on there, I think, is just the changes in energy prices. And they're a big net importer of energy. So as global energy prices go down, they benefit. But you see, the other thing you see, though, is that the difference between auctioning and output-based rebating for these other countries is pretty small. It doesn't make much of a difference. They're a little bit worse off for the most part, but it's not that different. Some of them are even slightly better off with output-based rebating. But with border adjustments, that's a different scenario, and it actually does, further change their terms of trade in, in a negative manner. So it is more costly for them, shifting more of the burden, the cost burden, onto them. So that, I think, is also a lot of the controversy. Although, one thing you could do is if you're imposing, a border carbon tax on imports, is rather than keeping the revenues, you can send it back. And that would be a way of mitigating that, at least that welfare effect on the developing countries. Okay. Okay, and then the final point I want to make is that if you're thinking about output-based rebating, like in the climate context, it really depends. The benefits from anti-leakage measures really depends on how much leakage there is and how big your coalition is, okay? So here we're comparing, so how much cost savings do you get from adding these anti-leakage measures compared to just having an emissions tax alone? And again, we're making sure we always get the same, emissions reductions across these three options. Of course, now as your coalition gets bigger, and I think, if I remember correctly, this was 20% global net reduction, global net reduction of 20% of the emissions of baseline emissions of the coalition. Okay, so as your coalition gets bigger, your global emissions policy is getting more ambitious, but also you're bringing in higher cost, some higher cost countries. So we see this black line here, which goes with the right axis. This is the cost, sort of the welfare cost of emissions pricing. So you see that's going up as the coalition gets bigger. As more people are included, the welfare costs of your your policy is getting more ambitious and your coalitions get bigger. So those total costs are going up. And then these are the size of the welfare gains on this axis, so they're different. So this is relative to the tax alone. And so we see here, if the EU is alone in the coalition, output-based rebating does get you a welfare gain of about 10% of what your costs were. But this is border adjustment for imports and full border adjustment, which also would be to basically give a rebate for exports. But let's just focus on the red one. So, so border carbon adjustments, though, get you about twice as much of the cost savings. If you have both the EU and the US in the coalition, you still get a gain from output-based rebating, but it's smaller, and you get bigger gains from border adjustments. So then you see here, though, as this would be all of Annex 1. This would be Annex 1 plus the basic countries. So here with all of Annex 1, you're starting to not see any gains at all from output-based rebating. So as your coalition gets bigger, then you have more people in it, so there's fewer trade partners to leak to. And the sufficiency cost that we talked about before, the sufficiency cost of not having the right signals for conservation or for consumers to find other products start becoming relatively more costly. Okay, because you don't have the same pressure from imports, and so what you're giving up with the policy is just as big as whatever leakage benefits you're gaining from it. Border adjustments, on the other hand, don't have that problem, so you still get some positive gains. The gains from border adjustments tend to shrink because there is as a percentage of the cost of the tax, because the cost of the tax is going up as the coalition gets really big. In absolute terms, though, they're still going up. And then we see, though, so once we have, you know, China, India, South Africa, those guys in the coalition, then output-based rebating has a negative impact on welfare. So the size of your coalition is also important, or this is basically how, you know, how the share of the emissions that you're regulating is an important factor, certainly in how desirable output-based rebating is, particularly if you're thinking about it as an anti-leakage measure. And in fact, in the Waxman-Markey bill, they actually had a kind of phase-out for the policy based on, you know, how many other countries, you know, what share of our imports were coming from countries that had adopted policies. So I think I'll stop there and turn over the last hour to Thomas.